I hope the stream is up. Let's wait. Yes, so okay. Yesterday we were checking out the Fluent SDK, Fluent docs. So today we are gonna continue that Fluent.xyz. No, that's Fluent Fluent.xyz. Okay, and now docs. Fluent Labs. Okay. So we had few questions yesterday about what these things are. I asked the team and they were pretty helpful. They told me bunch of things, bunch of answers. Like they gave me answers to all the questions that I had, and I found this repo while going through the GitHub, and it uh, talks about what rWASM is. That was one of the questions that we had yesterday. Okay, cool. Uh, I had a few questions yesterday. Let's open the VS Code, and in the VS Code, I jot down those questions. Okay, let's open folder blended app. Okay, in this we had note down those questions, right? Yes, here. So, what is rWASM? I found it. Then I didn't ask this part. Ask this part and this part. So basically, under the hood, they have all of them have. Let's talk about the addresses. Um when the address is deployed, the binary representation for all of them is almost is same. Like it's a binary representation, and that's how they interact with each other. So when we'll see more examples, we can understand how that works. But for now, that's the gist of it, where you don't really have to worry about it, and Fluent will take care of that. Then Fluent base is their example. Okay, we just have to do this. There is no need for example. It's pretty straightforward, and we can do it. Front ends, it will work the same. Just when this one is deployed, SVM, we have to see for Rust, the rWASM contracts that we deployed yesterday. You can just interact with that contract as a straightforward. What was this? Let me check something else. Not blended. Okay, so this contract, you can assume you can interact with this contract as a solidity contract. You have all the things and you have the interface, so you don't really need to worry about anything. You just need to call this as you do for EVM contracts. It's straightforward, very simple. Next, what was the next question? It it was, I asked them four questions. Yeah, I wanted to find the repo for Gblend. They said "Mm, it should be like this: Gblend." But I'm getting 404 error. I told them that hopefully they'll respond. Yeah, cool. Then we can just read this for today's stream. What is rWASM? rWASM, rWASM reduced WebAssembly is an EIP 3540 compatible binary intermediary intermediary representation of WASM. It is designed to it is designed to simplify the execution process of WASM binaries while maintaining 100% compatibility with original WASM features. Okay, let's check out that EIP 3540, what that is. Why don't we have this on EIPs? Yeah, so I was talking about why we don't have this on this. What was this? Changes relies on resort Ethereum.org website. EIPs. Peer review notice. At least let's read the starting part: abstract motivation and the maybe rational. Yeah, just to understand what it is. Hey, hi, whoever the third person. Hello. I know who the first two are, me and my brother. So hopefully it's Aditya. But yeah, cool. Abstract of 3540, and that 3540 is gonna be in UF, UF, EIP, Spectra, Upgrade, EIPs. Dude, why? And why the website we need is not the first one. eip.ethereum.org. Spectra. Okay. We don't see 3540 in here. 3540 so this is EOF EVM object format v1. Is there formal definition can be found in? Okay. So this gives us the total overview of what will be included. DevNet proposed inclusion, considered inclusion, scheduled inclusion. Oh no. Oh, definition. No, we don't need the definition. We just need to understand these. And why we are not seeing the EOF. EOF eip.ethereum.org. Is a series of EIPs. Okay. Has been implemented in following clients and projects. Oh, these are the series of EIPs that EOF. What is that? Which EOF comprises of, and we can see this 3540, 3670, 4200, all these things. EIPs, testing, okay. Nethermind, everything. R rEVM, everything. Okay, let's just go over 3540 and see what that is. Because rWASM is compatible with it, so I wanted to explore what 3540 is. Okay, abstract. We introduce an extensible and version container for EVM for the EVM with one-off validation at deployment time. The version described here brings the tangible benefits of code and data separation and allows for easy introduction of variety of changes in future. This change relies on reserved byte introduced in 3541. Okay. To summarize, EOF bytecode has the following layout: magic, version, section kind, section size plus 0 and section. Okay. When we read this, it'll click maybe. Motivation. On-chain deployed EVM bytes. On-chain deployed EVM byte code contains no predefined structure today. Code is typically validated in clients to extent of jump destination analysis at runtime, while single time prior sorry every time single every single time prior to execution. Understood? So the code just is validated um, based on the opcode. There is no structure for that. Maybe that's what they're saying. This poses not only an overhead but also a challenge for introducing new or deprecating existing features. Okay, validating code during the contract creation process allows code versioning without an additional version field in the account. Versioning is useful tool for introducing or deprecating features, especially for large changes such as significant significant changes to control flow or features like account abstraction. The format described in this EIB introduces a simple and extensible container with a minimal set of changes required to both clients and languages, and introduces validation. The first tangible feature it provides is separation of EOF data, uh, separation of code and data. This separation is especially beneficial for on-chain code valid on-chain, on-chain code validators like those utilized by layer 2 scaling tools such as Optimism. Okay, let's note this down. Optimism. A bit query. That's pretty cool. On-chain code validators. What is this? No, there is nothing. We'll try to find out what this means, or what how the optimism implements it. Next, because they can distinguish code and data, this includes the deployment code and constructor arguments too. Currently, they point A requires changes prior to contract deployment. Point B implements a fragile method. Point C implement an expensive and restrictive jump analysis. Code and data separation can result in ease of use and significant gas savings for such use cases. Okay. Additionally, various static analysis tool can also benefit through off-chain, though off-chain tools can already deal with existing code, so the impact is smaller. So what data and code not being separate, um, what issues it has, and how this might solve it, how separating them might solve it. That's what they're just telling here. So if you see any contract on chain and you see the bytecode, if there is immutable data in the immutable variables, immutable means like we set them in the constructor. That's that's what we need to understand right now. We can set those in constructor, and that data is saved in bytecode. But if you go and see the contract bytecode, there is no, you can't distinguish between which is the immutable variable and what's the actual code logic. That you have to understand the whole contract to see like which part is the code and which part isn't, and that's what they want to separate. Okay. non-exhaustive list of proposed changes which could benefit from this format, including a jump destination table to avoid analysis at execution time and or removing jump destination entirely. Who knows? I don't understand the implications of removing jump destination or what it might do. Introducing static jumps with relative addresses, the jump tables, and disallowing dynamic jumps at the same time, requiring requiring the execution of code section ends with a terminating instruction. Assumptions like this can provide significant speed improvements in interpreters, such as a speed up of 7% seen in EVM01. EVM01, the repo. That's the repo, and the PR request. Who knows? But probably that's the repo name and the organization name. Multi-byte multi-byte opcodes without any workarounds. Okay, representing functions as individual code sections instead of subroutines. Introducing a special section Introducing special sections for different use cases, notably account abstraction. Okay, we I did understand why they are doing that, but these proposed changes, I don't understand it. I did understand this part, which was simple. I don't know what are related static jumps and dynamic jumps, where you might have to deep dive um, into the EVM to understand what is static jump and what is dynamic. So this point I don't understand. I understand they are trying to do some jump tables, but why removing jump destination is useful, I don't know, or what are the implications. But probably jump destination is used for dynamic jumps. That's the whole idea. Multi-byte code, last three, I just I don't know how to go what that means for everything. Okay, specification, ignore the first para. Then, in order to guarantee that every EOF formatted contract is, uh, we can ignore this rest of the part. We just understood like what 3540 does. We can go back to our rWASM, because that's where we wanted to understand it. That's why we wanted to understand EIP 3440. Okay, here it is designed to simplify execution process, binary maintaining. Okay, key features: ZK friendliness. Where is okay? rWASM achieves ZK friendliness by having more flattened binary structure and simplified set of instructions. Compatibility: rWASM retains full compatibility with WASM, ensuring that all original WASM features are preserved. Important notice: rWASM is a trusted execution runtime and should not be run without proper validation. It is safe to translate WASM to rWASM and execute, as rWASM injects all the necessary validation into the entry point. Okay. Motivation: WebAssembly is an interpreted interpreted language, and binary format favored by many Web2 developers. Yes, I do know that. A bunch of WASM things happen on front end. I think Figma uses it because you can't write that much. They wanted to optimize their uh, front end because you use Figma in browser, right? But they were not able to do that with JavaScript, so that they moved everything from JavaScript to WASM. At least the components that were too process heavy, or they're consuming too much of CPU. I don't know. WASM is just more optimized for Figma. Other way around. Figma optimized their website using WASM. Okay, next part. Our approach aims to seamlessly integrate these developers into Web3 world, despite the challenges this integration presents. We prefer WASM over RISC-V or other binary formats due to its well-established and widely adopted standards, which developers appreciate and support. Moreover, WASM includes a self-described binary format covering memory structure, type mapping, and more. Unlike RISC-V, AMD, Intel binary formats, which requires binary wrappers like um, EXE or ELF. Okay. Uh, this basically says WASM is WASM has all the features inbuilt, and other formats don't. That's why. That's why they chose this language, this format, .wasm, basically WebAssembly. But what I don't understand is, if they want Web2 developers to come in, then why do? Because most of the people who are writing WASM probably are not using Rust. They are using C++ or C, or at least that's my understanding from all the things I have read. Rust is favored, but more people are writing C++ for WASM. Okay, let's go to next paragraph. However, WASM is not without its drawback, particularly its non-ZK friendly structure that complicates the proving process. This is where rWASM comes into play. Introducing rWASM. It is a specially modified binary intermediate intermediary representation of WASM execution. It retains 99% compatibility with original WASM bytecode and instruction set, but features a modified. No, I fucked up somewhere. It retains 99% compatibility with original WASM bytecode and instruction set, but features a modified binary structure that avoids the pitfall of non-ZK friendly elements without altering opcode behavior. The main issue with WASM is um, WASM is its use of relative offsets of type mapping, function mappings, and blocks block/loop statements, which complicates the proving process. rWASM addresses this by adopting more flattened binary structure without relative offsets and eliminating the need for type mapping validators, allowing straightforward execution. No, I don't understand anything. What is type mapping, function mapping, and block slash loop statement? But okay, those were the pitfalls. We at least understood that, and rWASM tries to resolve it. Benefits of rWASM: flattened structure of rWASM simplifies the process of proving the correctness of each opcode each opcode execution. The place and places several verification steps in the hands of developers. This modification makes rWASM a more efficient and ZK-friendly option for integrating Web2 developers into Web3 ecosystems. Cool. We're not gonna go over all these things. It's pretty pretty difficult to understand. But at least we'll try to go through we'll go through technology and structure you can read yourself, because I don't know what this thing is, the whole thing is. So I won't be able to explain it. Okay, technology. rWASM is built on WASM eyes intermediary intermediary no intermediate mediate representation, originally developed by Parity Tech, and now under Robin's ownership. We choose the Wazamaya virtual machine because its IR is fully consistent with original WebAssembly, ensuring compatibility and stability. For rWASM, uh, stability. For rWASM, we adhere to same principles, making no changes to Wasmize IR and only modifying the binary to enhance zero knowledge friendliness. So someone has created this thing, Wasm IR, and Fluent Lab is to using that and just improving the ZK part. Key differences: deterministic function flow. Functions are ordered based on their position in the code base. Block code replacement. Block loop replacement. Blocks and loops are replaced with BR friendly instructions. Okay, what is BR friendly? Um, don't know. Redesigned break instruction. Break instructions now support program counter offsets instead of depth level. No idea what it is. Oh, I know what program counter is because I have seen EVM bytecode, but I don't know what depth level is and how break instructions relate to it in WASM. Simplified binary verification. Most sections are removed to streamline binary verification. Unified memory segment section implements all WASM memory standards in one place. Removed global variable section. Global variable section is eliminated. Eliminate, eliminated type mappings. Type mappings is no longer necessary as code is fully validated. Special entry point function. A unique a unique entry point function encompasses all the segments. Hmm. The new binary representation ensures 100% valid rWASM runtime module from the binary. Some features are no longer supported but are not required by the rWASM runtime. Module imports, global variable memory imports, global variable exports. Cool. Few parts I understood out of this, which is this, half of this, and like 25% of this out of all these things. Okay, at least we know what rWASM is now. Cool. So should we? Yeah, that was the first question, right? Check here. Read more about how WASM works and now works. That's it. This part. Okay, this I haven't asked, but we can just modify it and see if that will work. And what was the command? Which it was gblend build rust dash r, and we have to cd into that project, which is greeting. Viper is invalid mode. Okay, so it's only solidity or fluent. So solidity or fluent, but we can create Viper implementation and it'll still work. Cool. Okay, I think that was it. Most of the part I don't didn't understand. So I don't blame you if you didn't. Uh, to understand rWASM, we need to know how WASM works, and that's where the issues start. We read EIP 3440, which was great. What else is here? No, nothing interesting right now. When they release SVM version, that will that will be interesting. Cool. So should we call the stream? Okay. Okay. I'm gonna end the stream early for today because it was mostly out of our skill level. Yeah, it was the whole stream just showed my skill issues. I know that, but we read something interesting, and tomorrow we are gonna jump into nil. So nil is like a good project. similar to Fluent that I want to explore. Here it is. Just a second. Documentation, and we have multiple things here. It's not. It's a very big documentation. Lot of things we can do. Get started. All these things are there, and I want to create something interesting. They have cookbook where implement the auction logic, English auction, swaps. Oh, cool. When I saw this last time, they only had this swap contract. Okay, there is still issue here. Like it doesn't really explain what's happening. They do this, but this is not much better from actually going in the GitHub section, GitHub repo and checking it. Let me zoom in. Sorry. I understand. I understand. So tomorrow we will go through all of this. Where where can I find? No, not this. Oh yes. You see, getting started guide. We are like there are a lot of things we can do on Fluent. We can do it with a straightforward EVM. It's not. It's not. If you want to deploy, it's very simple, straightforward, and that's why it's interesting because you can interact with other SVMs. So their value proposition is different than what nil provides, which is they provide ZK sharded EVM, and this is not an EVM actually. This is just Solidity supported VM. Um, because if you are changing where it was somewhere here, like what where was this? What opcodes they don't support, and there are multiple opcodes. So I'm pretty sure that doesn't make this an EVM. It's a EVM compatible thing, but it's not an EVM. So we are gonna see this and understand how it works, what uh, what it does, and how can we build on it. So that's the plan for tomorrow, and hopefully you liked today's stream. If you didn't, I'm not gonna blame you for that because I also didn't like that today's stream. It was very technical and very boring, but cool. If you like the stream, I'm happy with it. If not, I'm also happy with it. Cool. See you guys tomorrow, same time. You know the topic, and have a nice day. Bye.